Halo guys, Assalamualaikum warahmatullahi wabarakatuh. Pada malam ini saya akan memberikan informasi tentang bagaimanakah karakteristik daripada jet tempur pengebom atau bomber B-61-12 yang beberapa bulan yang lalu pernah dijatuhkan di laboratoriumnya Iran, yaitu pusat laboratorium pengolahan atau pengayaan nuklirnya Iran, yaitu di gurun pasirnya Iran itu ya. Di situ ada 2 bom yang dijatuhkan ya, dan saya bahas ini adalah pesawat jet tempurnya itu ya, dimana pesawat itu adalah pesawat yang notabene itu pesawat jet tempur yang paling tercanggih di zaman sekarang ini ya. Di saat-saat ini pesawat jet tempur yang paling canggih, paling modern, dan the best in the world ya. Jadi yang paling canggih di dunia saat ini adalah jet tempur bomber B-61-12 milik Amerika Serikat ya. Tadi tidak semua negara itu mempunyai jet tempur bomber B-61-12 ini ya. Jadi ada Cina sekarang sudah punya, Rusia juga. Namun tidak semua negara mempunyai jet tempur seperti ini ya. Jet tempur yang seperti sayap elang gitu ya, terbang tinggi ya, yang besarnya bukan main, lebih daripada 12 meter lebarnya dan beratnya lebih dari 1 ton ya. Jadi pesawat jet tempur itu benar-benar sangat canggih dan modern sekali ya, dan itu jarang dipakai ya. Baru di dunia ini jet tempur bomber B-61-15 baru dipraktekkan oleh Amerika sendiri ketika Amerika menjatuhkan 2 bom rudal ya di tempat pengayaan atau pengolahan.
Step-by-step process the U.S. president follows to launch a nuclear triad B-2 Spirit stealth bomber. It starts with the biscuit. No, not the snack, but a card containing the gold codes that authorize a nuclear attack. Once that order reaches the cockpit, the pilot drops a thermonuclear gravity bomb. A challenge. While the U.S. military had a massive engineering requirement, they needed to fit not just 1, but 16 of these nuclear bombs inside the B-2 Spirit stealth bomber. So how did they manage to pull that off? Well, inside this tiny cylinder, they've packed 150 kilotons of power. It uses a precise multi-point initiation system to channel,
yaitu di tempat pengayaan.
Step-by-step process the U.S. president follows to launch a nuclear triad B-2 Spirit stealth bomber. It starts with the biscuit. No, not the snack, but a card containing the gold codes that authorize a nuclear attack. Once that order reaches the cockpit, the pilot drops a thermonuclear gravity bomb. A challenge. While the U.S. military had a massive engineering requirement, they needed to fit not just 1, but 16 of these nuclear bombs inside the B-2 Spirit stealth bomber. So how did they manage to pull that off? Well, inside this tiny cylinder, they've packed 150 kilotons of power. It uses a precise multi-point initiation system to channel X-rays and ignite a massive secondary fusion. We're breaking down exactly how this intricate 2-stage nuclear engineering creates a 900-meter fireball capable of collapsing buildings and shattering windows over 5 miles away. But here is the real question. If this is just a free-falling gravity bomb, how does it actually hit a target? The secret lies in these spin rocket motors that stabilize its fall. More details, all in the video ahead. This is the most heavily guarded nuclear procedure in human history, and we are here to simplify it just for you. The nuclear triad gives the United States 3 ways to end a war: land, sea, and air. The B-2 Spirit is the air leg, the flexible arm of the triad. Unlike a missile, it can be recalled. Unlike a submarine, it can be seen until it decides to disappear. Here is exactly what happens when the president makes the call. The process begins with the president and the football, the black satchel that follows him everywhere. But it's not as simple as saying launch the nukes. He must authenticate his identity using a plastic card known as the biscuit. He reads a challenge similar to this code: Delta Tango, Delta Tango. This message travels to the war room at the Pentagon building and confirms whether it is valid or not. The president then selects a specific major attack option from the menu of war plans. But how exactly is the order communicated? The order travels instantly to USS Trotcom in Omaha, Nebraska. They format an emergency action message, EAM, just like we animated the Minuteman nuclear silos and the Trident submarine missiles a couple of days ago. But across the globe, a high-frequency radios crackle to life. A voice broadcasts a message like this one, Sky King. A string of alphanumeric breaks away and heads toward enemy airspace. As they approach the enemy coast, the pilot gives the order to fence in. They turn off their radar transponder. Inside the bomb bay, the rotary launcher assembly powers up. The B-6112 nuclear bombs are energized. The red pre-arm lights on the dashboard turn green. The B-2 is the only nuclear weapon system that puts a human eye on the target. The pilot flies directly over the coordinates. But dropping a modern nuclear bomb isn't just about pushing a button. The B-2 Spirit doesn't just drop the new B-61, it talks to it. It guides it. It literally spins it like a football. So what actually happens inside the cockpit during a nuclear run? Let's break down the step-by-step process of how a B-2 executes a B-6112 strike. Phase 1 starts long before the target is in sight, the revolver setup. Unlike a fighter jet that hangs missiles on its wings, which ruins aerodynamics and stealth, the B-2 hides everything inside. The B-6112s are loaded onto a massive 20-foot-long rotating cylinder called the rotary launcher assembly. Think of it like the cylinder of a giant revolver hidden in the belly of the plane. This is where it gets smart. Before the drop, the pilot uses a digital interface to dial in the bomb. They can set the explosive yield, how big the boom is, and the burst height while they are still in the air. Phase 2, the stealth penetration. The B-2 is a penetrating bomber. It doesn't shoot from safety, it flies directly over the target. As they approach enemy airspace, the pilots fence in. This means retracting antennas, killing all emissions, and going dark. But what if the enemy is jamming GPS? That's where a system called RATS comes in, the Radar-Aided Targeting System. The B-2 takes a quick radar snapshot of the ground, figures out exactly where it is without satellites, and feeds those coordinates to the bomb just seconds before the drop. Here comes Phase 3, the drop We are now directly overhead. The pilot authorizes the release. The massive bay doors snap open. This is the most dangerous second of the entire mission because that open cavity suddenly makes the stealth bomber visible to radar. The launcher rotates the bomb to the bottom, but gravity isn't fast enough. The bomb is forcibly ejected downwards with pneumatic pressure to punch through the airflow. Bam! Doors closed. Stealth restored. This phase 4 is where the B-6112 shows off. It doesn't just fall. Immediately after ejection, spin rocket motors on the bomb's body ignite. These rockets spin the weapon violently, spiraling it like a perfectly thrown football. This gyroscopic effect keeps it stable. Then the tail kit takes over. It uses an internal navigation system to steer itself. This means the B-2 doesn't need to be perfectly accurate. The pilot can drop it from miles up and the bomb will fly itself to within meters of the target. Finally comes phase 5, detonation. A radar altimeter watches the ground. If the pilot selected airburst, it detonates above the surface, flattening buildings with a massive shockwave. But if the target is a deep bunker, the bomb waits, engineered in such a way that it fits inside this gravity bomb. This compact cylinder holds the power. A radar altimeter watches the ground. If the pilot selected airburst, it detonates above the surface, flattening buildings with a massive shockwave. But if the target is a deep bunker, the bomb waits, it slams into the earth, and then it detonates, crushing the target from the inside out. That is the terrifying precision of modern nuclear warfare. Why is this one of the smallest nuclear weapons? Well, it's designed and engineered in such a way that it fits inside this gravity bomb. This compact cylinder holds the power of 150 kilotons of TNT. But how does it actually work? It starts here on the left, the primary stage. This is the trigger. See that intricate sphere at the bottom left? That's the multipoint initiation system. It's designed to detonate high explosives all around the core at the exact same microsecond. This perfectly symmetrical explosion crushes the plutonium pit in the center, starting a fission reaction. Once that primary explodes, it doesn't just blast outwards. It follows intense X-rays down this channel, the interstage. These X-rays strike the secondary stage on the right. They turn the plastic foam casing into plasma instantly, compressing that cylinder of fusion fuel until it ignites. This explosion creates a fireball roughly 900 meters wide. At around 2.3 miles or 3.7 kilometers, most residential buildings collapse, widespread fatalities occur, and eardrums rupture. Out at 5.5 miles, windows shatter and injuries occur, followed by intense thermal radiation. But why is the B-2 Spirit the ultimate choice for nuclear deterrence? To find the answer, let's take a look inside the airframe. At the front is the composite wingtip. This section comprises the ribs of the outer part of the wing. Both integral fuel tanks can hold approximately 167,000 pounds, which translates to about 75,000 kilograms of fuel, which is a significant amount. Just a small comparison, this aircraft's fuel reserve can fill up 2 tanker trucks, making it an insanely gas-guzzling machine. Moving further back, there is another section of the fuel tank. These fuel tanks were specifically designed to penetrate deep into Russian territory, about 6,900 miles, which is around 11,000 kilometers. Furthermore, it can travel double that distance deep into enemy lines while avoiding radar detection, thanks to this rotary air refueling system that extends all the way out, as shown here. This maximizes its range to 12,000 miles with the Boeing KC-135 Stratotanker and allows it to remain airborne for 44 hours. That is almost 2 days in the air. Let's take a look from the side profile. As you can see, it has its engine buried deep in the airframe with an S-curve in front and behind. This is how it reduces its heat signature. Air is sucked by the fan rotor as it draws in, which undergoes powerful compression in both the low pressure and high pressure compressors. As the air enters the combustor, this is where fuel injection occurs. This process generates a continuous combustion of fuel and air, reaching temperatures of more or less than of 1,000 degrees Celsius. The resulting heat causes the gas to expand, leading it to escape from the combustor with high energy, flowing through both the high and low pressure turbines. As a consequence, the turbine blades rotate. The energy liberated by this process drives both the compressor and the fan, thus producing thrust. Just a reminder, the B-2 Spirit does not use afterburner because as a stealth bomber, it has to compromise on speed to lower its heat signature. The exhaust from the engines is mixed with ambient air before it exits the airframe. This significantly lowers the temperature of the exhaust, hence reducing the heat signature suitable for this stealth bomber to remain undetected as much as possible. For a conventional aircraft, it has ailerons at each wingtip that move opposite one another to roll the plane. It also has elevators at the tail that affect pitch, and the rudder controls yaw or rotation. However, if we look at the B-2 Spirit, it doesn't have all of those control surfaces like a standard aircraft. You'll notice that there are no leading edge slats. The massive wing, which essentially comprises the entire aircraft, generates enough lift on its own. Instead, the B-2 Spirit has outboard elevons located here close to the split drag rudder, mid-elevons and inboard elevons near the engine exhaust. These control surfaces are located all over this area and move independently as a single unit. They can move opposite one another to achieve roll and work together for pitch control. They also use a combination of both for maneuvers that require some roll and pitch at the same time. As stated, almost every aircraft has a rudder and elevators to turn and stabilize the plane, but the B-2 Spirit has none of these. This is because any vertical structure would reflect radar waves, which is why they had to design it without vertical stabilizer or rudder at the rear. Instead, they use this technique of split drag rudders to provide directional stability and control in a flying wing aircraft. But there is a catch. As opposed to conventional rudders, the control efficiency of split drag rudders is typically low for small deflection angles. That is why the B-2 Spirit turns very slowly compared to other military planes. Each split rudder consists of two separate panels that swing out vertically in opposite directions. When the left split rudder opens, it produces drag and causes the B-2 Spirit to yaw to the left in the direction of the open split rudder. The same effect occurs with the opposing right side split rudder. Split rudder. This is what happens inside the cockpit when the pilot pushes the left rudder pedal. The left split rudder opens, causing the aircraft to yaw to the left. Similarly, when the pilot pushes the right rudder pedal, the right split rudder opens, causing the aircraft to yaw to the right. The B-2 Spirit composite can be divided into several parts. Here, we find that all the edges are made of fiberglass epoxy to reflect radar, while the largest part of the wing is primarily made of graphite epoxy. Interestingly, the crew station assembly is